Hello, Block C. Block B says hello. Say hello.
Hello.
All right, it's like we're from the past. Anyways, your opener today. Please pause the video so you can read through the opener and answer the questions.
Hi, Tessa.
After you're done answering the questions, press play and we'll go through the solutions together.
She's gonna cry. She is really gonna cry right now. It's okay. The light goes on.
All right, so to answer the first question, the car's displacement, I actually want you to write down displacement. And remember from yesterday, displacement is where you are relative to where you started. So our car traveled 1.5 miles away, but the car came back. So what's the total displacement? 0. And the unit on that would be miles. Now part 2 is a different question. It asks you what's the total distance the car traveled. Obviously that answer is going to be what? 3 miles. So there's a good example of the difference between displacement and total distance. 3 is a little bit stranger situation. What we're going to do is draw an x-axis, put 0 on there. This is going to represent the OHS parking lot. There are probably people parked outside the lines because there's snow.
There's not snow anymore. It's just all
That's somebody parked in the OHS parking lot. Anyways, away is a leftward movement. Block B, you need to be quiet. So starting at the OHS parking lot, we moved away from the school. We're going to model that leftwards. So we went away how far? 1.5 miles. So that's going to lunch. So here's our lunch destination. And then after we ate lunch and returned to school, we start at negative 1.5 and go back to 0. This is a model of the car's travels on a number line. All right, so our notes for today are in section 8.1. And our example today goes from our example yesterday. We were talking about a particle traveling. And all we knew about the particle was its velocity, ds dt, was equal to t squared minus 8 over the quantity t plus 1 squared. For this example, you do need to have your calculator out, so go dig that out of your backpack. / not a backpack, because you don't have those, right? Okay. All right, our question today asks us to find the total distance the particle travels. So we're going to show how to do this in a couple ways. So recall from yesterday we had the particle's velocity. It looks something like that. Obviously, when we integrated from 0 to 5, our velocity equation, that gave us the displacement. But to find the total distance, this is where I need to use absolute value. So we're going to do the integral setup. We're not actually going to solve the integral, but we'll show how to set that up, and then we'll show how to find this on your calculator. To find the total distance traveled, we need to break up our interval. So we need to locate our zeros. Does anybody remember what that 0 was from yesterday, approximately?
1.25.
Yep. And what we should be doing on our calculator is getting that actual value with 3 decimal places, but this is fine for now. I'd be integrating from 0 to 1.25. And then I'd be adding the integral from 1.25 up to 5. But this isn't even quite correct yet for the total distance equation. What am I missing here? Yes, which one do I need the absolute value on? Why is that?
It's below.
Yes, this part is below the x-axis, so I need an an absolute value sign on that integral. Now, one option for typing this into my calculator is to type in the integral from 0 to 1.25 of velocity. Do that, take the absolute value, then type this one in and get that value. Or what you could do on your calculator is type in n int, or on our calculator is fn int. And I'm going to show you what the notation looks like, and then we'll practice typing it in. I'm just going to take the absolute value of the whole equation, comma x, comma, and then I'm going to integrate from 0 to 5. This is a trick for putting everything above the x-axis. So it will take care of this first interval where our function was below the x-axis. It flips it above, and then it leaves this one also above. This is a shorter way of finding the total distance traveled than typing in two separate integrals. Okay, so now what I want you to do on your calculator is actually practice typing that in. So one way you can type it in to save yourself a little time is just go to your y equals and type in the equation. Remember to use parentheses. And this will save me a little bit of time when I'm typing my integral. So now I'm going to find the absolute value symbol, which is under math. And then to pull up the equation, instead of typing it in here again, I'm going to hit the vars button, V-A-R-S. Then I'm going to arrow over to y-vars. Hit 1 for function. And that enters whatever function was that I had typed in y1. Close out the parenthesis for the absolute value, comma x, comma 0, comma 5. So to get the y1 again, you hit variable, V-A-R-S, arrow over to y variables, and then function. And the answer that you should get is 42.587. I don't think we had a unit yesterday when we were talking about our particles, so the total distance will just be in units.